Okay, good morning, everyone. All right, y'all ready to get started? Any questions before I get going here?
I was wondering, could you go over question 9 on the homework?
Yes. What page, just to make sure?
I believe it was 67.
Was it a graphing of a line 1/2 y, that one?
Yes.
Okay. So we're asked to graph 1/2 y equals -1/6 x plus 3/2. Okay, so this is the homework for the intercept method. So the intercept method is where we figure out what the x-intercept is, then we figure out what the y-intercept is. So my first kind of question back to you is, did you leave it as fractions or did you clear fractions?
So I tried clearing fractions, but I think I got thrown off because like the y was on the other side of the equal sign. And so I just didn't know how to like set it up, I guess.
Okay. So what did you use? What did you multiply both sides of the equation by to clear the fractions?
I did 6.
Yeah. Okay, good. So you multiply the left side by 6. And then when you multiply the right side by 6, you will have to distribute that 6 through the, you'll have to put a parentheses around the 2 terms on the right side. And that way it passes through to both terms. Now on the left, where's my cursor? There we go. On the left, we do 6 times 1/2 or 1/2 of 6, which would be 3. So we get 3y here. And then when you multiply the 6 times -1/6, the 6's cancel, right? And you should just get -x. And then when you multiply the 6 times the positive 3/2, I'll do that on the side. I'll do it like this. If you go straight across 18/2, which is 9, the other way you could do it would be to reduce the fraction, divide 2 in here, 2 in there, you get 3/1, which, sorry, 3 times 3/1, which is 9 also. So is that okay, Grace? Or was that issue?
No, yeah, that was fine. Yeah.
That's fine. Okay. Now, the next step is to actually go find the intercepts. So to find the x-intercept, what we will do is we will set y equal to 0 in this equation. So 3 times 0 equals -x plus 9. So 0 equals -x plus 9. And then you have a choice here. You can move the 9 to the other side, or you can move the x to the other side. What did you do?
So I think this is just where I got confused. I didn't know if I could move the x over or not. And I think that's just where I got confused.
Yeah, so look, I'll show you 2 different ways, okay? One way you could do it is you could take this equation and you could subtract 9 on both sides. And then you get -9 equals -x. And you'd have to get rid of this negative. So you divide through both sides by -1. And that would give you 9 equals x. That makes sense, Grace? Yeah.
Yeah, sorry, I was muted. Yes.
That's all right. Okay, now the other way you could do it is to, instead of moving the 9 over, you can move the x to the other side. So you just add x to both sides. And you get x equals 9, which is the same answer. So either way, it'll work. Okay.
Okay, thank you.
Yep. Now to get the y-intercept, I'll just finish the problem out. To get the y-intercept, we set x equal to 0 in the equation. And of course, the -0 is just 0. So we just get 3y equals 9. And then divide both sides by 3. So we get 3. So the x-intercept, if we write the x-intercept as a point, it's the point 9, 0. And the y-intercept written as a point is the point 0, 3. And now we will go graph this. All right. So 9, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. There's 9. We'll put a point here. And then the other one is 0, 3. So up 3, 1, 2, 3. We put a point there. And then connect those with a straight line. Okay. Good. Are there any other questions?
Yes.
You're still muted.
10.
Okay. Say again. I didn't hear any of that.
Number 10, 2x equals 8.
Okay. 2x equals 8. So 2x equals 8. Well, there's no y here, right?
Yeah.
There's just an x. So if I divide both sides by 2, I get x is 4, right?
Mm-hmm.
Now, last class, we talked about two special types of lines where is it? Here we go. Vertical lines and horizontal lines. And we said a vertical line is always going to be written in the form x equals a number. And a horizontal line is y equals a number. So we have x equals a number, don't we?
Yeah.
So it's going to be a vertical line. And it's going to pass through whatever this number is, that's where it's going to be on the x-axis. So I just need to, you have to kind of know that when you look at it. You don't want to go, you don't want to do the intercept method because there's both variables don't appear. So if only one variable appears in the equation, you should automatically start thinking horizontal, vertical. So I'm just going to go 1, 2, 3, 4. Here's 4. And I'm just going to draw a line that goes vertically through that 4.
Okay.
And I'm done. Okay. Any others?
Yeah. Number 68. Question 13.
13. Oh, hold on, my program's not working. Let me start this up. This problem?
Yeah.
Okay. So let's read through this. The graph of a line may be represented by more than one equation. For example, these two equations that they give us both define the same line. So what we've seen, what we've seen already is that when we have an equation, we can always move things around. We can clear fractions. We can solve for y. That's what we did last class to use the slope-intercept method for graphing. When you have an equation, you're always allowed to manipulate it. So when you're given an equation like this one here in yellow, it may look completely different than the one here in blue, but they may represent the same exact line. So the first thing says here to find the y-intercept for the line, for this line here, which is the yellow one. Okay, so for that one, if I was doing this, looking at this, and I wanted to find the y-intercept, then all I would have to do is set x to 0, right?
Yeah.
Now, I could clear the fractions also, right? I could clear these fractions out. So it's kind of up to you. Do you want to clear the fractions, or do you just want to set x equal to 0 to find the y-intercept? Totally up to you.
Yeah, let's clear the fraction.
Clear? Okay, so we're going to have to multiply both sides of this by what? Look at your denominators. 4 and 2.
Yeah, by 4.
12 would work, but is it the smallest number? That's the multiple of 2? I mean, that's a multiple of both?
Let's see. 6.
6 would not be a multiple of 4, so we can't use
No.
6.
Sorry, I was thinking out loud, sir.
That's all right. So 12 is a multiple of both, but it's not the smallest one. 8 is a multiple of both, but it's not the smallest one.
But it doesn't go into 3 either.
Oh, 3 is not in the denominator, though.
Oh, that's right. I'm sorry. Sorry.
No, it's okay. Good. No, I'm glad you pointed that out because.
So it'd be 4.
4. Yeah. How about just 4 itself? 4 is the smallest number that is a multiple of both 4 and 2. Good. So we'll multiply both sides by 4. Multiply 4 here, and on this side, just I'll put the 4 next to it like that and distribute. So when I do that, I get 12x. When I do the 4 times negative 1/4, the 4's cancel. So all I'm left with is negative y. And then on the right side, I'll just do 2 goes into 4 twice. So the right side should just be 6. And now we have no fractions. So I'm going to find the y-intercept. And to do that, I'm going to set x equal to 0. And that goes away. So I just get negative y equals 6. And divide both sides by negative 1 to get y by itself. And you get negative 6 for the y-intercept. Or as a point, it's 0, negative 6. Okay.
Yeah.
Now, part B says this is the same line. They told you that these are the same line. Okay.
Mhm.
But notice that this one, notice, and this is the key thing to notice, it is solved for y, isn't it?
Yeah.
Solved for y. So if I do the same thing right now to find the y-intercept, if I set x equal to 0, I get y equals 12 times 0 minus 6. This goes away. I just get y is negative 6, right? Same answer.
Yeah.
So what they're asking you now is which of these was easier to do? Right? Was it easier to do part A or part B? I mean, for part A, we had to clear the fractions, right? Then we had to divide by -1 here. So it's a little more work, right?
Yeah.
This was easier. And the key thing they're trying to point out is when it is solved for y, right? When this thing is solved for y, it's always easier to find the y-intercept if it's solved for y. That's kind of the key idea here. Now, this homework comes from the section on the intercept method, but we learned last class this very important equation, y equals mx plus b. And I told you, look, whenever it's solved for y, right? Whenever we have it solved for y, what is this number over here always going to be? What does b in this equation always give you?
The y-intercept.
Right.
Y-intercept, right? So I guess what I'm saying is when you did this homework, you didn't really technically know this equation, but you can see that the -6 right there, that's the b, right? These are all connected.
Okay.
Okay.
Yeah.
So on your test, on your exam, I will ask you to graph lines. And when I ask you to graph them, I'm not going to tell you which method to use. It's completely up to you. You can use the intercept method or you can use the slope-intercept method, right? We have 2 different ways of doing it. I don't care what you use, but sometimes one method is a little easier than the other. Like if it's easy to solve for y, then just go solve for y and then graph it using this. If it's complicated and hard to solve for y, like I'd say the yellow one here is hard to solve for y, we have to do some work, then I would just do the intercept method. Plug in, find the x-intercept by replacing y with 0, find the y-intercept by replacing x with 0, and solve. But I don't care the way you do it. Both ways you should draw the same line no matter what.
Okay.
Okay.
Yeah.
Could we do number 11 on page 68?
Keep your eyes on the road, please, Emily. I know you're sitting in the parking lot. I'm just messing with
Yeah, I'm not driving.
you. I know, I know.
It's pretty simple. It's not complicated. I just am trying to figure out how to do it correctly.
Okay. Okay, write, it says write an equation of a line with an x-intercept of -2, 0, right? -2, 0. So they're saying write an equation of a line. So that means everybody could possibly have a different sort of answer here. They just want you to give me an equation so that when I draw it, it's going to have this x-intercept. So let me just draw it first. All right. We have an x-intercept of -2, 0. So we know that our line must go through here, right? There are an infinite number of lines that go through there. I mean, I could do this one, or I could do that one, or that one, or I could even do a vertical line, right? So it's completely up to you on how you define your line, okay? So this is a tricky question because you have to think about it. The line in general, now again, we have to remember that this was before we had the slope-intercept form. This homework was before we had this formula, okay? So if I was trying to figure out what, an equation of a line, what I know is that when I plug in -2 for x, right? -2 for x and 0 for y, the equation needs to be true, right? That's what I need. So let me do it, and then I'm going to ask you to make up your own. So I'm going to try and make this happen. So what I'm going to do is this. I'm just going to start making this up. 3x plus 4y equals, now let me think through this. I'm just making this up. If I plug in 0 for y, this goes away, doesn't it?
Yeah.
And then what I need is that when I plug -2 in for x, this is going to be true. So if I plug -2 in for x, what would I get here?
-6.
-6, right? So I'm going to make this side -6. Let's just check. Does this work? If I gave you that and I asked you for the x-intercept, what would you do? Set y to 0, right?
Mhm.
That would go away. You would get 3x equals -6. And so x, if we divide both sides by 3, would give you -2. And so I have an x-intercept of -2, 0. So this is an example of a line that would have that x-intercept. That's my answer, okay? So let me help you do it again. I'm going to do a completely different one. Emily, since you asked, I'll ask you. I'm going to just make this one, I'm again making up a number, 5x minus 3y equals, and then here's the thing we have to figure out. So what do you think, Emily? When I plug in 0 for y, I need to get, 0 for y and -2 for x, I need this to be true. So what should I put over here?
-10.
-10. Now check it yourself. Plug in 0 for y and -2 for x, and you will get a true statement. So this line should also go through here. And you could do this for anything. I could make up any number, -4x plus 11y equals, and then now if I plug in 0 for y and -2 for x, -2 for x is going to turn this into an 8. So I need this side to be 8. Does that make sense, Emily? I know this is a tricky question, so I'm glad you asked about it.
Yes,
So
it makes sense.
These are all correct answers.
I just wouldn't have known to plug in the X and then put that on the other side.
Yeah. Yeah. Well, there's different ways you can approach this. That's the way I think I hope makes sense.
Mhm.
Okay. All right, good. This has been good. Anything else?
Can we do page 75, number 4?
Okay, good, good. So number 4. Now, the instructions here are to write this in slope-intercept form, then to identify the slope and the y-intercept of the line. So what they mean by that is slope-intercept form is what we studied last time. Slope-intercept form means that we have to make it look like y equals mx plus b. Okay, that's what slope-intercept form is. That means you need to get y by itself, okay, on one side of the equation. So we need to isolate this y and get everything else away from it. So again, you have choices here. I'm going to subtract the 1/4 x on both sides. And that will get rid of it on the left, leaving me with negative y equals. Now on the right-hand side, you cannot put these two together because one of them has an x, the other one doesn't. So I'm going to write it this way. Now I could have written it this way. I could have put the 2/3 take away 1/4 x, but I decided to write negative 1/4 x plus 2/3. And the reason I did that is because eventually I want it to look like this, a number in front of x plus a number. So I put the x term before the number that's by itself. That makes sense, everyone?
Yeah.
Now I have negative y, I need it to be positive y. So I divide everything by -1. And all that really does is changes the signs of everything. Everything that used to be positive will be negative. Everything that was negative becomes positive. So we get y equals positive 1/4 x and then minus 2/3. So there it is. That is the slope-intercept form of the line. All we've done is solve for y. As soon as you solve for y, you should have that should now have you in slope-intercept form. Now from this, we need to identify the slope and the y-intercept. So the slope is the number in front of x, which is going to be 1/4. And the y-intercept is always this number, including the sign here, so negative 2/3. Now, it doesn't ask us to graph the line, but we may as well because we've come this far. Remember, the slope tells you your rise over run.
Mhm.
And the y-intercept, right, is going to tell you a point on the graph. So to graph this line, I will start off by going to the y-intercept, which is at negative 2/3. This is going to be kind of hard. Let's say that let's say that's -1 right there. And this is negative 1/3, negative 2/3. That would be right there. That's my y-intercept. And then to get to another point, I need to go up 1. So here's +1. So I need to move up 1 unit. I don't know if y'all can tell, but 3 lines this way. Sorry, 3 lines, not 2. So if I jump 3 lines, that's 1 unit, the way I drew this. So if I need to go from here up 1, rises 1, I'm going to jump up to there. And then I need to go to the right 4. So 1, 2, 3, 4. And I draw a dot here. And then connect them with a straight line. Now again, the problem didn't ask for that drawing. It just asked for the slope and the y-intercept.
Could we do number 6 on page 75?
Yeah. I don't
It's
mind.
another
drawing-
one of those that doesn't have the X.
Yeah, so if it doesn't have an X, that should automatically be making you think, okay, this is, well, if it's missing one of the 2 variables, you should be thinking vertical or horizontal line. Okay. Now, to get the y by itself here, you have 2 options. You can divide both sides by 2/3. Okay, that's one option. Let me do it. Let me go ahead and do this. You get y equals, now on the right side, be careful. This is -2 over or divided by negative 2/3, which is the same as -2 divided by negative 2/3 And division is the whole keep dot flip. Keep dot flip. -2 is a fraction. We can write it over 1. And then hopefully you see just the -2's cancel. And you just get 3. So you get y is 3. So is this vertical or horizontal? This is the part you have to remember. So they're saying, yeah. So they're saying y is 3, right? Y is your up and down. So if y is 3 all the time, that means you have a horizontal line. That means you have a horizontal line that goes up 1, 2, 3, and you have a horizontal line like this. Now, another way you could have done this, and this is the way I prefer to do it, but I haven't done it this way much, is instead of dividing by 2/3, you can multiply both sides of this by the reciprocal. So 3/2, and do the same thing over here, 3/2, right? What am I missing? Hold on. 3, 3. Hold on, I'm having a. What am I missing? Oh, you know what it is? I see what I did. I made a mistake. Do y'all see this? I apologize. I was supposed to divide both sides right here by what?
+2/3.
+2/3. I don't know why I put a negative there. Do y'all see that?
Yeah.
What the hell am I doing? I don't know why I did that. Did y'all see that? Did anyone see that when I didn't? Wonder what the hell is he doing? No? I slipped it by.
But he
you,
was
didn't I?
subtracting the last equation, so maybe you just like.
Yeah, I don't know, but it's not normal for me to do something like that. Okay, so let's see how that changes the answer, because that's going to make a huge impact. That should be a positive. So when we do the division over here, this is positive. And then this is positive. And we flip it, it's positive. And when we cancel these, we don't get 1. What do we get?
-3.
Negative, right?
3, yeah.
So this will be negative. I apologize. That should be a -3. That changes our graph, doesn't it?
Mm-hmm.
It's still y is -3 all the time, but our graph's now down. It's down here.
So the main thing that I was struggling with was on the top of the page, it says to write the equation in slope-intercept form.
Okay,
So how would that be written in slope-intercept form?
great question. This is slope-intercept form. Because remember, slope-intercept form looks like this, right? Yes. So the number, whatever number you have here, in this case, we have the y, right? We have the -3, but we don't have anything for x, do we? But that's because the slope of the line, what is the slope of the line? Remember, we talked about this last time. If you have,
Oh, it's straight, so it's like 0, right? Something like
yeah,
that.
if you have a positive slope, it pitches up, right? If you have a negative slope, it pitches down. But what if it's flat? Well, if it's flat, you have a slope of 0. And if this m is 0, what happens if that m is 0? Well, then this is all dead, isn't it? It's just a 0, so you don't even need to write it. So
It's just
y
like y
equals
equals b,
-3.
right? That's it.
Sorry, this should be, yeah, -3, we fixed it. So it was, Emily, it was in slope-intercept form. You just didn't, you were wanting there to be an x in there, right? But the slope
Yes.
0 kills off the x.
Okay, that makes sense.
Mhm. Now, when it comes to vertical lines cannot be written in slope-intercept form. You know, when it's like x equals a number, it's impossible to write that in slope-intercept form. And the reason it's impossible is because of what I talked about at the very end of class last time. And that is when it comes to vertical lines, the slope is undefined. So it is impossible to write it as y equals mx plus b, because this is undefined. So when we just write, you know, X is a number, then that's it. That's the only way you can write a vertical line. Okay, it's 10 o'clock. Let's move on. If you have more questions, I'll be happy to entertain those, you know, German office hours or something like that. But good questions. I liked us going through all that. So last class, again, we were talking at the end about when it comes to the slope-intercept form of a line, the M controls the pitch of the line, right? So if the M is positive, it goes up. If it's negative, it goes down from left to right, right? If you're reading this like a book, up means left to right going up, and then down means left to right, we're going down. So now what we're going to do is we're going to talk about two special classifications of lines. All right. So given two lines, I'm going to call the first one L1 and the second one, I'm going to call it L2. Okay, so let's say we have two lines given to us. Then L1 is, L1 and L2 are either one, parallel, two, perpendicular, three, neither. And if they're neither, we call that skew. Now, when I sit here and say, okay, I give you two lines, they're either parallel, perpendicular, or neither, we need to all understand what parallel and perpendicular mean. Now, I know a lot of you probably do, but let's talk about it because it's actually kind of an interesting idea. Let's talk about parallel first. All right, so two parallel lines. What does parallel mean? Now, don't answer yet. So I want you to think about this question. I'm going to give you 1 minute, and then I'm going to ask for several people to kind of respond. Act like you're trying to explain it to someone who has no idea what parallel means, and you had to like verbally explain what parallel is. All right, let's take a minute. I'm going to go refill my coffee. Okay, who wants to volunteer to explain to me? Angelique?
Gibbs. Oh,
So it means that the equation is going to be like X equals, and it's also the line is like straight up.
So I have no idea what parallel means, and you're trying to explain to me what parallel means, right? So you're saying straight up?
Yes. Like if you were to hold your finger up, I guess, and then
Okay.
like parallel.
So when I talk about parallel, or when you're talking about parallel, are you just talking about one line, or is it actually like, are you
It could
comparing?
be- Wait, what? Sorry.
Is it just one line? Like if you have one line, can I say that that line is parallel? Or do you have to have two lines and be comparing them to each other?
Do you mean like if you have like a horizontal line and like a parallel?
No, maybe your idea of what parallel is off. It sounds to me like you might be confusing parallel to vertical and horizontal somehow.
Okay, yeah, I am. Never
I
mind.
think that's what it is. Okay, I heard someone say something. Who said something?
Oh, that was me, sir.
Okay, Joshua, let's let Joshua go for it. Let's see if
I think she was talking about perpendicular.
Yeah, I think so too. I think so too. But we'll get to perpendicular in a minute.
so
Let's go with parallel. So are you
Parallel
gonna explain it
means
to me?
parallel is kind of like, it's like a mirror. Think of a reflection, but with graphs, the parallel would have to be the reflection of the first line's points. Like this, like an inverse,
Reflection over what though?
a reflection over whichever axis the first line is over.
Okay, so let me try this. If I
Axis.
have, let's say here's our X and Y. If I draw this line, and then I draw this, maybe let me exaggerate this a little more. If I draw this line, and I draw this line, those are actually reflections of each other over the y-axis. Like if I take this, if I just take them and flip, they land on each other. So but I don't think that those two lines are parallel. Maybe that's not what you mean, but I think that's what you said,
Ah, dang.
right? I mean, right, like these two lines are drawn, and if I reflect them over the y-axis or over the x-axis, they are reflections of each other, but they aren't parallel. Let's try it in someone else.
What I got is they have the same slope and a different y-intercept. The lines are parallel to each other and will never intersect to each other. Did that make
Okay.
sense? I don't know.
Okay, that's what I was looking, like language, you know, like you're trying to explain this to a young child, right? Like what two parallel lines are. They don't intersect each other, right?
Okay.
Is it now what you said about the slopes is correct, but that's a
Okay.
little bit more than I was looking for. Just explain to me in words what parallel means. So you said it's two lines that don't intersect.
To each other, yes.
Okay. Does someone want to add their own kind of?
So the way that I learned was always that parallel parallel lines is two lines that will go on and on and on, but no matter how far they go, they'll never intersect each other. And
Yeah.
the way I learned perpendicular was they can go on and on and on, but at some point they will intersect.
Okay. At one point, right?
Yes.
So parallel, that sounds similar in terms of the definition that you're giving me, is that two lines that when I draw them, they are never going to hit each other, right?
Correct.
Does anyone have anything to add to that?
I would say that they have to be, I think they have to be going like in the same direction, I guess. Like it would be two vertical lines right next to each other, two horizontal lines right next to each other that keep going and never touch.
Yeah, so two vertical lines would be parallel and two horizontal lines would be parallel. Absolutely. But they don't have to be, right? Like as long as, like you said, if we just kind of pitch them the same way,
Oh, okay.
right, then we would still have parallel. And I think it was Anaris had said, if they have the same slopes, then we should have parallel. But generally speaking, and I think we've kind of closed the case on this, is that to have two lines that are parallel, let's call that L1 and L2, the idea here is that they would never hit each other. No matter how far I drew them out, they would never hit. So if that would mean that the slopes of these lines would have to be exactly the same, wouldn't they? The slopes would have to be exactly the same. Because if the slope of line 1 and line 2 were different in any way, eventually they would cross each other somewhere. So parallel means they don't intersect. But that means, another way of saying it is that the slopes are equal. The slopes are equal. That's what it takes for two lines to be parallel. Their slopes must be equal. Now, I'm going to get into an example in a minute, but this is where I normally in a class like to take a little detour to talk about this, because right now, like, have y'all seen that show, Who Wants to Be a Millionaire? That's a kind of an older show, but you know, these shows where they sit you down, they give you these little trivia questions, and then you get more money for the harder questions. So if you were sitting down in that chair and you were at the $1 million question, and I asked you, do two parallel lines ever intersect? Your answer would be what?
No.
No, right? Okay, so here's our detour. That's not exactly true, all right? So let me show you where it's not true, okay? So I got to go back to like historical, take a historical trip with you here. I'm going to go to Google real quick. Let me bring up my web browser. And I'm going to Google cave drawings. Okay, these are drawings done like by cavemen, cave women, cave whatevers. Okay, here's a drawing. Okay, this is the oldest known cave art was made by Neanderthals, not humans. So this isn't even humans. And when you look at these things, what would you say? I mean, that's obviously supposed to represent a picture of some people, right? What would you say about that drawing as far as its artistic level? Is that pretty advanced, or is that what you would expect from like a first grader, kindergartner? You know what I'm saying? I mean, not to pick on them, not to you know, give them a hard time, but they weren't great artists, were they? They weren't great artists, but they did their best, right? They did their best. So there's a reason why over time we got better and better and better at drawing. Let me bring up something else. Realistic sketch. I'm just picking the first thing that comes up here. It's better. That's better, right? Wow, is that a pencil sketch? Wow, that's crazy, right? So what's the difference? What are we seeing as the difference here? What's the major difference between those drawings?
Detail.
Years.
The detail, right? There's detail, but there's something else. It's this one, like, look at that one. Okay, this one right here. Oops, I shouldn't have clicked on that. Whoa, that took me to a website. So you see that one? That one's okay, right? It's not terrible, but compare that to this one. Like there's something different, or this one. Okay, like that one and this one. Like what's the difference here? There's something different. I know it's the detail, but it's more than the detail. Right here, look at this one. Does that nose look like it's actually coming out at you? Does it look, does your eye interpret that nose as being any closer to you than the ears do?
Is it dimension?
It's like depth, right? There's like this depth that's missing. Do y'all agree? It's like this three-dimensional depth that this picture somehow captures, right? Now they're both done on a flat sheet of paper, but one of them gives you depth. The other one doesn't have the depth. And the cave drawings did not have depth, right? They definitely were just like stick figures, you know? Now, the reason why pictures have gotten better has a mathematical background. And here's how it works. And I'm gonna take you to kind of an illustration, something that you can probably relate to, all right? If you were to stand on a train track, right? this train track that just goes and goes and goes. There's no trains on the train track. You're just standing on the track, right? And it just goes and goes and goes. What does it look like to you the train tracks are doing?
They're getting smaller.
They're getting smaller, right? And they get closer and closer together, right? Yay, nay? So, okay, let me back up. Let me do this. I think this will work. I'm going to draw you a picture, right, to show you my artistic abilities here. I'm going to draw you a road with a couple of buildings on the side. Ready? There's the street. That's the road. Here's those little marks that you keep you in your lane, okay? And here's a building to the side, and here's another building to the side, and another building to the side, and another building to the side. Okay, so we're kind of looking from the top, aren't we? Down. But I'm making sure that I follow all the rules. These two lines are parallel, right? So they're not going to hit each other. These lines are also parallel to the road lines, and those aren't going to hit each other. Make sense? Those lines, everything in yellow, those are all parallel to one another. So when I drew them, I made sure that they didn't hit each other. Make sense? And my drawing kind of sucks, right? So what I'm going to do now is I'm going to draw you the same picture, but I'm going to try and trick your eyeball into thinking that it's more like realistic and it has depth. And to do that, here's what I'm going to do. I'm going to create something called a vanishing point. So if you've done any drawing in your life, you know what I'm talking about here. And from that vanishing point, I'm going to bring the road back to us like this. Okay. And then I'm going to have my little marks in the road like this. Okay. And then my buildings on the side are going to look like this. I'm going real fast because I don't have time for this, but to be more detailed, but okay, which picture is more realistic? First one, second one. Second one, right? I mean, that's got that depth that we're talking about, right? But we know that in real life, right? If this road existed with these buildings, we know that in real life, these lines are parallel, right? In real life, they're parallel. But in my picture, they're not parallel, are they? But they all go to the same point. If you were to follow these lines, everything that's parallel goes to the same point. And so I had to break the rules that you've learned about parallel lines in order to trick your eyeball into seeing something that's three-dimensional on a flat sheet of paper. And so this is called perspective geometry. Oops, perspective. Perspective geometry. The geometry that we are doing in this class and that you've learned your whole life, you know, the whole idea of like two parallel lines don't intersect, the slopes have to be equal. This is correct, but this is known as Euclidean geometry. And that's what we study in most. I mean, I know all of you are pretty much going to stop at this class and don't do more math, but if you were going to take pre-cal, Cal 1, Cal 2, you would stick in Euclidean geometry until you get to Cal 3. And Cal 3, we go outside of Euclidean, but in Euclidean geometry, two parallel lines do not intersect ever, all right? And they have the same slope. But if you're talking about perspective geometry, then all parallel lines must intersect at a single point. And that point's called the vanishing point. And so that's how we got better over time, is understanding math and understanding how to trick our eyeballs into seeing something that's really not there. I mean, it's a flat sheet of paper. So if you're sitting in that $1 million question, right, and they ask you, you know, do two parallel lines exist, or sorry, intersect? That would be a terrible question. because they would have had to have said, do two parallel lines intersect in Euclidean geometry? They would have to be more specific, because in some cases it does, they don't, and in other cases they do. Does that make sense? Does all this make sense? So why am I even showing this to you, right? Like, how, I'm not going to test you on this. I'm not going to have you draw me something. The whole reason I'm showing this to you is because there's this kind of idea that I think is important as you're going through your education and as you're learning more and more about the world, either formally through school or informally through life, right? I think it's always important to keep something in mind. And I have a little analogy for it. I don't know if y'all can see this, but in the back corner, I have my daughter's fish tank. It used to have a bunch of fish in it, and we're down to one. Okay, he just won't die. But that fish tank right there, those fish that are in there, I like to make this analogy that we are like the fish in this fish tank, okay? In the sense that here's the fish tank, here's us, all the little fish in here, right? Now, do you think that this fish in here, I know that they don't have brains that can process like we do, but if it had any idea of its own existence, do you think it has any idea or concept of what an alligator is? Or let's say what a camel is, or what the dog in my backyard is? Like, does it have any concept of what my refrigerator is? Like, no, right? Like, its universe is here. Like, that is it, right? That is its universe. This whole idea of parallel lines and perspective geometry is just to let you know and remind you, as a student of math and as a student of life, that a lot of times we are in a fishbowl, and you have to understand that there are stuff outside of this universe you live in that you may be completely unaware of at this point in your life. And so you always have to be open to the possibility that things are not quite what you think they are. Does that make sense? Okay, that's it. So even as me, you know, my old age, I'm still so open to learning things and never believing that something is absolute, because it might just be in my fishbowl. I think it is, but outside my fishbowl may not be. So, okay. That was more of a little philosophical detour we took. And I wanted to show off how good I can draw. I'm kidding. All right, so back to this. Two parallel lines, back to Euclidean geometry, back to our fishbowl. To say that they're parallel means they will not intersect. So, and the slopes have to be the same. So now what I'm going to do is I'm going to give you two lines, and I'm going to ask you if they're parallel. Okay. So how about this? If I said y equals 4x plus 5, let's call that L1, that's line 1. And L2 is 4x plus y equals 10. My question is, are these parallel? Well, let's look at line 1. Can anybody tell me what the slope of line 1 is? Just by looking at it.
4/1.
4/1, good. So the slope of this, I'm going to call that M1, okay? I'm going to say the slope of that is 4/1, or I'm just going to write 4. Everyone agree? The reason why I could say it so quickly like that is because L1, that equation was solved for y, right?
Isn't it
Was it
if the
ready in
slope
that
is the
form?
same, but
Pardon
the
me?
why isn't it like if the slope is the same but the b part is different, it could possibly be parallel?
Yeah, that means they are parallel. Exactly.
I
If
know.
the slopes have to be the same, and then the y-intercepts need to be different so that you have two different lines. If you have the same y-intercept and same slope, then you're talking about the same line, like it's the same line repeated. So look at the second line. It's not solved for y, is it? So I need to solve this for y before I can just pick the slope off like we did on this one. So I'm going to solve for y on that one. And to do that, I'm going to subtract 4x on both sides. So the equation of this line is negative 4x plus 10. Everyone okay with that? Just taking 4x away on both sides? So what's the slope of this line?
-4.
-4, right? So the slope of that line, I'm going to call it the slope M2 because it corresponds to the second line. That's -4, right? So asking, are these parallel? Well, that would mean they would have to have the same slope, right? Are these two slopes the same? No, right? 4 is not equal to -4. So these two are not equal. And therefore, are they parallel? No. Okay, they are not parallel lines. So checking to see if two lines are parallel means you have to figure out what the slopes of each of those lines are, which means solve for y and figure out the number in front of x, and then compare them. If they're the same number, then they're parallel. Got it? Now, let's talk about perpendicular. So visually, and I'm not going to go off on a big tangent on this one. So perpendicular lines well, let's talk about what they look like first. Perpendicular lines have the property that when you draw them, they intersect at one point, but they intersect at what we call a 90-degree or a right angle. So it's a perfect T. It doesn't have to be straight up and down. It can be any sort of rotation, but they have to maintain that little T to be called perpendicular. Now, of course, if you take a vertical and horizontal line, those would be perpendicular. But you can twist it a little bit and it's still perpendicular. So what do you think the relationships between the slopes are? So like, let's say for this particular line, what if it has a slope and it's M1? And what if the slope of this line is M2? We know that if those two are equal, right, that they're parallel. But what's the relationship that makes them perpendicular? What do you think? Any guesses on that?
Their slopes are the inverse of each other.
What do you
Like a
mean?
negative and a
Wait,
positive.
no, it's like, so
Alexander? Yep.
their slopes are the opposite of each other.
Opposite. Okay, Alexander, is
Like
that
one
what you're going to say?
Yes, sorry. One slope negative, one slope positive.
That seems like that would make the most sense, right? Like, let's just say, just to illustrate, let's just say that this was 4, okay? It would make sense that to be perpendicular, that this one would maybe be -4? Wouldn't that kind of make sense? It's not. All right, unfortunately, it's not. It's close, but it's not. There's one additional thing. We have to take, in order for it to be perpendicular, we have to look at the slope of 1 and write it as a fraction. And then the perpendicular one has to be this fraction flipped over and change the sign. So if I have a line that has a slope of 4, a line that would be perpendicular would have to have a slope of -1/4. Make sense? These two numbers are called opposite reciprocals. Opposite reciprocals. So it's the opposite. So this one was positive, this one will be negative. That means it's opposite. And the reciprocals is just the fractions flipped. So let's see if you really get this. if we had a slope, let's say we had a slope of one line and I told you that it was 2/3, what would the slope of another line have to be in order for them to be perpendicular? What would it have to be?
-3/2.
-3/2. Okay, these would be perpendicular. Let me give you another one. What if the slope of one of the lines was -5/7? What would the slope of the other one have to be?
+7/5.
+7/5, and then they would be perpendicular. How about this one? What if the slope of one of the lines was 1/5? What would the slope of the other one have to be?
-5/1.
-5/1, right? Which would just be -5. Then they would be perpendicular. Does this make sense? For parallel, they have to be equal. That's easy to check. But to be perpendicular, they have to be this opposite reciprocal thing, which is a little bit more complicated. Now, just so you believe me, I was making fun of that picture. It's probably worth like $1 million. I didn't read any details about it. It's probably like $1 million picture. Okay, so just so you believe me, I'm going to graph y equals 4x plus 3. Okay, so what's the slope of this line?
4.
4, right? 4. So we thought maybe if we did -4, we would get perpendicular, right? Let me show you. If I do -4, right? Can you all tell these are not perpendicular to one another? So -4 doesn't work. Now, I said if I do -1/4, it will. There we go. So the red one has a slope of 4. The green one has a slope of -1/4. The blue one has -4, and it doesn't seem to work. But you can tell, hopefully, that the red and the green are a perfect little cross there. Okay, so you ready? I'm going to give you a problem to try and work on your own. L1 is 2x plus 3y equals 12. L2 is, let me see here. (3x plus 2y equals 15). Are these parallel, perpendicular? I'm just going to put perp, or neither, which means skew. So I'm going to let you work on this for a few minutes. Can somebody just tell me what you're going to do? It's like, what are you going to do now?
Get them in slope-intercept form.
Okay, so solve each one of them for y, and then
Look at the slopes of both the equations.
yep, and that's it, right? Compare them. If they're the same answer, it's parallel. If they're opposite reciprocals, they're perpendicular. And if they're not equal and not opposite reciprocals, then the answer is neither. So take a few minutes, I'll let you work that out, and then we'll answer it together. Okay, we're running out of time. We'll go over this in a second. I want to just let you know the ebook or the packet we have doesn't have a lot on parallel and perpendicular lines, but I like this topic. So just do page 78, number 20. But then I want you to do this problem right here. And I'm giving you a line, okay? And I'm asking you to sketch it. Now, I'm not telling you how. You can use either the intercept method or you can use the slope-intercept method. It's up to you totally. But then after you do that, I want you to find the equation of any line that would be parallel to this. So you have some freedom there. You just got to make sure that they're parallel. So your equation has to have something in common with this one. And then sketch that one. And then again, find the equation of any line that's perpendicular to this one, this given line, and then sketch it. So you should have a final picture that has 3 lines on it. Does that make sense, everyone? Now that's number 1. Number 2 is to do the same steps for a different line. Okay, so given 5/4 x plus 3y equals 1/8. Do the same steps. I'll make this a little smaller. So I think what this problem does is it kind of gives you an opportunity to demonstrate a lot of the things that we've done with lines. You get to practice sketching. You might have to clear some fractions. You might need to find X and Y intercepts. And then you have to use this idea of parallel and perpendicular and how the slopes are impacted. And see if you can't put it all together and answer these questions. If you get stuck on anything, we can talk about it when we come back. I'll put this back up, but let me go up here and solve these. So if you take this first equation and solve it for y, you first move the 2x to the other side, which makes it negative 2x. And then you divide both sides by 3. Okay, so you move the 2x to the right, comes negative 2x, divide every single term by 3, and you get this. So I know that the slope of that first line is negative 2/3. Now I do the same thing on this one. Now what I do is I take the 3x to the other side, so it becomes negative 3x. And plus 15, sorry. Then I divide everything by 2. Now 15 divided by 2 is a decimal. I'm just going to leave it because it's actually not important to me. All that's important to me is the slope. So what can you tell me? Are these parallel, perpendicular, or neither?
Is it neither?
Neither. Neither. See, these aren't the same numbers, right? These are not the same numbers, so it's not parallel. And they are not opposite reciprocals. They're reciprocals, but they're not opposite, right? We would have needed this one right here to be positive 3/2 for us to say that they're perpendicular. So in this case, neither would be the answer. Okay, we're going to call it a day. I'll zoom out a little bit more so maybe you can see all this. Well, number 2, it's the same steps from here. So I think that should be it. Okay, we're good, right? Another week has come and gone. So have a great weekend. And I will see you. Our next test isn't until I think it's 3 weeks from today. Is that right? No. Well, let me just double check. When is our next test?
I think it's October 5th.
October 5th is what we're scheduled for. So that is, yeah, well, not quite 3 weeks. We have 2 more full weeks of class, so 4 more class meetings, and then we have our test.
Cool.
Okay. All right. I'll hang out if you have any questions, but y'all have a great weekend.
Thank you, you too.
Thank you.
You too, sir. Have a good weekend.
Professor,
Yes.
is the video recording for last meeting gonna be up?
It should be. Let me see. I had some issues with YouTube. Let me go. I thought I updated that yesterday. Let me just double check. Playlists. Where is it? Okay, so you're talking about from 9:14, right?
Yes.
Yeah, okay, I'll make sure it goes up. I don't know why it's not there. 9:14. Oh, you know what? Hold on. I made it public. Yeah, there was an issue because at the end of class, I was talking to a student and it was kind of like confidential. So I wanted to make sure that that didn't get on. I had to like edit the video, but let me see. I should. No, but I did it. I edited the video. Let me see. Where is it? Okay, I will do it right now.
Okay.
Okay.
Thank you.
And this video from today, it's going to take a little while.
Okay. I just
Okay.
needed that one because I missed last class.
Yeah, see, it would have been 14th, right? Yeah,
Yes.
right here. Yeah. Okay, yeah, I'm gonna go ahead and download it. Yep, I'll get it right now, okay?
Okay, thank you.
Okay, thanks for letting me know.
All right. Have a good weekend.
You too. Up and down like this. I'm going to put a dot. Page 75. Yeah, just do on page 75, 6. So on those, just be careful. What you're going to have to do on those is first get them all solved for y. So you have to take each of those equations, move everything over to get y by itself, and then use what we learned today.